Hi there, and welcome to this lesson on Pure Mathematics 3. And in this lesson, we're looking at the graphs of exponential functions. And we'll be considering functions of the form f of x equals a to the power of x. That's what's meant by an exponential function, where a is greater than 0. We need to consider two possibilities. First of all, what happens if a is bigger than 1? And then secondly, we'll consider what happens if a is less than 1, but still positive, still greater than 0. Well, if a is greater than 1, what happens if x equals 0? You'll have a to the power of 0. Anything to the power of 0 is 1. So if x is 0, then f of x will equal 1. So it doesn't matter what a is. An exponential function of this form will always cross the y-axis at y equals 1, because anything to the power of 0 is equal to 1. What happens as x gets bigger and bigger and bigger? So as x tends towards infinity, heading towards the right, then a to the power of x, that's going to get bigger and bigger as well, as long as a is bigger than 1. So as x tends towards infinity, y is going to tend towards infinity as well. That's really just saying as x gets bigger and bigger, y is also going to get bigger and bigger, which means it's going to head up here somewhere. What happens as x tends towards minus infinity, heading towards the far left on the graph? But as x tends towards minus infinity, we'll have a to the power of minus infinity, which is 1 divided by a to the power of infinity. So it's 1 divided by a very, very large number, getting bigger and bigger as x gets bigger. So that's going to tend towards 0. So as x tends towards minus infinity, y is going to tend towards 0, which means it's heading down here. Now, nothing strange happens in between. So we know the curve starts here. It will cross through the y-axis at 1, and then it's going to head up here. So it'll look something like that. Okay, I'll let you have a go at doing these yourself, just to see what happens as you do change the value of a. So sketch on the same set of axes the following graphs. Y equals 3 to the x, y equals 5 to the x, and y equals 2 to the x. And remember, you are just doing sketches. You don't need an accurate scale or anything like that. Pause the video, have a go, and come back to me again when you're ready. Okay, let's have a look. So first of all, y equals 3 to the x. Well, you just got to get the right general shape, that's all. So it's going to head towards 0, it's going to cross at 1, and then it's going to head up like here. Any value of a bigger than 1 will give you that general shape. They all look the same. What if we change 3 to 5? Well, if we change 3 to 5, everything happens more quickly. So it's going to get bigger more quickly, and it's also going to head towards 0 more quickly. So if we sketch the curve, you'll notice here it gets bigger quicker than 3 to the x, because 5 is bigger than 3. But also it gets smaller more quickly. So it cuts underneath the graph of y equals 3 to the x when you pass through 1, because you'll have 1 divided by 5 to a large number. Y equals 2 to the x, well, that's going to get bigger more slowly than 3 to the x, and it's also going to head towards 0 more slowly than 3 to the x. So you'll get something that looks a little bit like that. Okay, we said there were two cases. The second case is what happens if a is less than 1, bigger than 0, but less than 1. What happens if x is 0? Well, you've still got a number to the power of 0. It doesn't matter what the number is. Anything to the power of 0 is 1. So this doesn't change. If x is 0, f of x is still equal to 1. So exponential curves of this form, they all cross through the y-axis at y equals 1. Crossing here, same as before. However, the rest is different. What happens as x tends towards infinity? So that's moving towards the right as x gets bigger and bigger and bigger. Well, as x tends towards plus infinity, y is going to tend towards 0, or f of x is going to tend towards 0. Because a is less than 1, you'll have something like a half or a quarter to the power of a bigger and bigger number. And that will get smaller and smaller and smaller. So as x tends towards plus infinity, y tends towards 0. That means the graph is heading over towards this direction. What about on the other side? As x tends towards minus infinity. When as x tends towards minus infinity, the opposite thing happens, and y will get bigger and bigger and bigger. So it'll head up here. And again, nothing strange happens. It passes through 1, starts here, finishes there. It'll have a shape something like that. And again, it doesn't matter what the value of a is. If a is less than 1, that will be the general shape that you get. Okay, a bit like the first example. Have a go at doing this. Sketch first of all y equals a third to the power of x, then a half to the power of x, then a fifth to the power of x, all on the same set of axes. Pause the video, have a go, come back to me when you're ready. Okay, let's have a look. So y equals a third to the power of x. You've just got to get the general shape right, and all of these functions look the same. So it'll look something like that. Coming down from here, crossing through 1, and then heading towards 0. What happens if you change the bottom number to 2? If you change the bottom number to 2, the denominator to 2, things will happen more slowly. So it'll still get bigger and bigger, but not as quickly. It'll still head towards 0, but not as quickly. Change the bottom number to 5, well, it's a bigger number on the bottom, things happen faster. So when it gets bigger more quickly, and when it gets smaller more quickly. And you get something that looks a little bit like that. Okay, example 3. I'll let you have a go at this yourself first again. So once more, we're sketching a third to the power of x, same as the one we did just now. And then have a go at sketching this, y equals a third to the power of x minus 2, indicating where the curve cuts the y-axis. I'll let you have a go, and then I'll talk you through it. So pause the video and come back again when you're ready. Okay, let's have a look. Well, y equals a third to the power of x we do just now. It looks something like that. Now, the easiest way to sketch a third to the power of x minus 2 is using some work we did in a previous chapter. We've adjusted x by taking away 2 from it. Now, if we take away 2 from x, what that gives us is a translation in the x direction of plus 2. So this whole graph is just going to shift to the right by 2 units. And you get something a little bit like that. You've just got the original graph, the green graph, and it's just moved right. It's translated right by 2 units. We've been asked to find the y-axis intersection point. So this point here. Now, that's the equation that we've got, y equals a third to the power of x minus 2. The y-axis intersection point is where x equals 0. So we just need to put x equals 0 into this, and that'll give us a third to the power of 0 minus 2, which is a third to the power of minus 2. Now, a third to the power of minus 2 is exactly the same thing as 3 to the power of plus 2. So you do 1 over a third, which is 3, and change the power from minus 2 to plus 2. 3 squared is 9, which means this crossing point here will be at 9 on the y-axis. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 104 and have a go at exercise 5A. Thanks very much for listening, and cheerio.